Hello, this is Anthony Redamonte with Copy Controls. Today I'll be showing you how to use CML to initialize a EtherCAT network. So here in CML, it's C++ source code, and so we have motion control libraries, and we have our file that we've created. Mine is called CML PVT example. I'm using as this for this video, and within our within our file that we've created, we'll have the main function. And so in our main function here, we have some standard lines that are pretty common in all the examples. Our CML debug that creates a debug log that we can use, and then these that just open up the hardware, create the network. So if defined, what's that really talking about? Well, in the first line here at the top, we have this this define use can, or so if you want to use EtherCAT, you'd comment this out, which is what I've done. Comment this out, use EtherCAT. So use can is not defined. So now I go back to the main main function here. If defined, use can, it's not, so we're going to go with the elif will be true, and that's to use this IP address. So this is the IP address of the adapter I'm using to connect it to the drive. So if you want to double check what IP address, you just go to the command prompt and you would just type in ipconfig /all, and that would give you all the IP addresses of the adapter and everything on the network. And so, so that's, you put the IP address in there, and then we are going to be creating an EtherCAT network, this net. And so we'll be initializing the hardware, opening the network, and then I have an ME3, so I've created 3 axes here. So so we have 3 amplifier objects, and the ME3 has a 400 microsecond update rate. So what that means is that I have to set the sync period to be an integer multiple of 400 microseconds. The nearest whole number would be 2,000 for that. So 400 times 5 is 2,000, so it's just 2 seconds. So that's what I'm setting the sync period to. So again, if you want to just look up the ME3 as a 400 microsecond update rate for the position loop and the velocity loop. So if we go to data sheets, you can find your, this is only for the ME3 and the ME4. So if we go down here, right here, it says 400 microseconds. So for the velocity and position loops. So that's what we're doing there, setting that ampSettings object using and setting the sync period. We can also disable node guarding, but that's a little risky because node guarding really helps for if you unplug your drive, you get a node guarding error. So if you have a bad connection, that node guarding will disable the drive. But if you wanted to disable the node guarding, you just uncomment that. So here we're initializing the first axis. We're setting the node ID to -1, and then we're passing the ampSettings, which has the sync period in it. So amp 0, which is the first axis in our amp array, right? That's how you do that. And then for the second axis, all we do is we just make it a subaxis, a init subaxis, of the first axis. So it's amp1, which is the second axis because we're indexed at 0, init subaxis of axes of amp0, which is axis A. So really it's like axis B dot init subaxis of axis A, comma 2, which is the number of the axes we're talking about, the second axis. And then likewise for the third, it's just like for the second, amp2, init subaxis amp0, comma 3. And and then below here we have the linkage object. I've created a linkage object that contains all three of the axes, so I can command all three axes to perform trajectories. So here also I have some SDOs that are setting the motor position for all three axes to 0. And so hopefully this is helpful in explaining this. So yeah, just a little note: you don't the ampSettings here, since these are all sub-axes on multi-axis controller. The ampSettings only needs to be applied to that first axis, and that's also the axis that gets past the -1 node ID. Okay, well, I hope this was helpful in explaining how you would initialize an EtherCAT network in CML.